Hello everyone. So as you have probably guessed at this point, we have one more theorem of similarity, that is side, side, side. So side, side, side says that if each side of one triangle is the same constant multiple or scale factor as the corresponding side of another triangle, then the triangles are similar, and therefore the corresponding angles are equal. So in our picture, we have that AB over DE is equal to AC over DF, which is equal to BC over EF. Hence, we know that all these pairs of angles must be the same. Now, seems pretty simple to use. It can be a little tricky, but it's just setting up proportions with all the sides. So, let's get started. We have this following problem. Given the side lengths shown in the diagram, prove that AE is parallel to BC and AB is parallel to DE. Okay, when you see or think about parallel lines, you think congruent angles. If we can show something like that alternate interior angles are the same or congruent, or that corresponding angles are the same, if we can show one of those parallel line properties that are true, then we can prove that the lines are parallel. Easiest one I would say is show alternate interior angles are the same. Well, how can we do that? Well, we have two triangles, no angle measures, but we have all the side measures. And we just learned about something called side, side, side similarity. So let's start comparing some of the sides of the two triangles. So easiest way to do this, because just by visuals alone, it's hard to tell which triangles are going to overlap. So let's look at the numerical values. Starting with triangle ABC, what is the smallest side? Well, that would be the side AC, which has a length of 4. So then let's compare that to the other triangle AED. Which is the smallest side of AED? Well, that would be AD, which has a side length of 8. Now, is that proportionate? If everything goes right, it should be proportionate with some of the other pairs of sides. Well, the next easiest choice would be, well, what's the biggest side of ABC? That seems to be BC, which is 6. And the reason I'm doing this is because it's easy to find the smallest and biggest sides, and they're the ones that must go together in these ratios. Biggest side in one triangle goes in the same ratio with the biggest side in the other. So what is the biggest side in EAD? It seems to be the 12AE. Then finally, we have that medium length side AB, and that would match with ED. So let's fill in the values. AC is 4 over AD is 8. Just be careful, AD is AC plus CD. Now that just reduces down to 1/2. Okay, is that the same as BC over AE? Well, let's see. BC 6, AE 12. Well, that also reduces down to 1/2, so it's looking pretty good. However, let's try the last one. AB, which is 5 over ED 10, and we also get that that's 1/2. All the ratios are the same. All the sides are proportionate. All the pairs of sides are proportionate. So what that means is that we have similar triangles. Triangle. Now this part's a little tricky, lining up everything. Just again, I'm going to start with the smaller one, ABC. And then similar to triangle, Well, if we look at the path ABC, like A to B to C, A to B is that medium length of 5. And then from B to C is the largest length, 6. So when I write my triangle out over here, it's got to be in that same order. So we're going to start from D to E. That's the medium length. So I'm going to put DE. And then from E to A is the largest length. So the final one is going to be A. So again, it has to travel kind of along that same path. It went the middle, then the big. Like here, middle, then big side. Not super important, but it kind of is, in all honesty. So now that we know that all these ratios are the same and the triangles are similar, now we know that some angles must be the same. So what angles will be the same? Well, let's start with angle. How about CAB? Which one would that match up with? CAB. CAB. Well, you notice that this angle is between the smallest and the medium. Well, what other angle is between the smallest and the medium in the other triangle? That would be the angle at D, or ADE. And what do you know? We have AB and ED, both things we would like to show are parallel, and both part of the angles we're using. And we can think of AD as a transversal. And because of that, we are in the interior of the two lines, AB and ED, the interior inside. And the angles are congruent on the alternating sides. So that means we have alternate interior angles are the same. So what this does is prove that AB is parallel to ED. And the reasoning is because alternate interior angles are the same. And that can only be true if the lines are parallel. So is there anything else we could come up like that? Well, we want AE and BC. Well, that's a little weird. BC is right here, and AE is right here. So what could I do there? Well, if I notice angle, let's cut this off real quick. Angle, and I'm just gonna pick BCA. BCA. That is congruent. Well, BC to A goes from B to C is the biggest side, C to A is the smallest. So we need the same setup in the other triangle. So that would be the angle. E to A, biggest side, and then A to D, small side. So the angle EAD. Those would be the corresponding angles for that. And what do you know? We have the same thing. AE and BC are both sharing this transversal AD or AC, or however you want to imagine it. And on the interior of these lines, these parallel lines, they're on the interior, and the equivalent angles are on opposite sides. So hence, same reasoning as before, this is going to prove that AE is parallel to BC. And that is the problem. And a great way to use side-side-side similarity to discover some interesting properties of angles.